Hello and welcome to Living Proof, the joint podcast of maths.org and the Isaac Newton Institute. I'm Marianne Freiberger.
And I'm Sarah Hart. So the Cambridge Festival finished just last week. For those of you who don't know, it's an annual celebration of the world-leading research happening at Cambridge. And as every year, the Isaac Newton Institute contributed to this mathematical offering with a public lecture. This year's talk was by the mathematician Sarah Hart, and it was called Life in Lilliput, the Mathematics of Fictional Realms.
Yeah, it's an intriguingly titled talk, and we'll find out more from Sarah in a minute about what that was about. And Sarah has done an amazing number of things in her career, from pure mathematical research to the history of maths and to public engagement work. And we're hoping to find out more about all of this and how it all fits together in this podcast. So Sarah, why don't you start by introducing yourself?
I'm Sarah Hart, I'm a mathematician and a writer.
So Sarah, please give us a brief overview of what your talk was about at the Cambridge Festival.
So I spoke about the mathematics of being very large or very small. And in particular, if you think of creatures and people that we encounter in books, in fiction, in films, giants, tiny people like the borrowers or the Lilliputians from Gulliver's Travels. What's life like for them? Can they really exist? And, what can mathematics tell us about that? And the answer is a lot. So, that was what the talk was about.
And the book signing was such a bonus. So do you want to talk a little bit about that? What inspired you to write Once Upon a Prime?
Yeah, so I've always been, as well as a mathematician, I've been an avid reader. I've loved books, I've loved fiction my whole life, and would always have at least one, probably several books on the go. So stories to me and narrative are part of who I am and what I enjoy, and that influences my mathematics as well as the rest of my life. So when I became a mathematician, I always continued this enjoyment of fiction. And Once Upon a Prime is about the connections between mathematics and literature. The seed for that project in the book eventually was reading Moby Dick as an adult. I hadn't read it when I was younger. I mean, I think in America everybody has to read it at school, and so therefore everybody hates it, right? But luckily for us in Britain, we're not compelled to read it. I came to it as an adult and loved it, but what struck me right from the start was lots and lots of mathematical references, allusions, metaphors that Herman Melville uses. And I got, gripped by the book, which is a fabulous book. But then I thought someone must have written about, all this mathematics that Herman Melville uses. So I thought I'll go and read some papers about it. I'm an academic. I'll look at the journals. And there really wasn't very much. So that prompted me to write about Herman Melville and about the mathematics he uses in Moby Dick. And from that developed this big project to think about the connections more broadly between mathematics and literature, and that's where the book came from. And I had such fun writing it. Yeah, it's been really, really enjoyable.
So you said that fiction has always been a big part of your life, and that it also even influences your mathematics. Now, I first met you when we were students.
Yes.
And back then...
It's 5 years ago, yeah.
Yeah, exactly. We just finished our PhD. But back then you were doing your PhD, and it was in pure mathematics, right? Can you give us a little bit of a glimpse of the mathematical research that you do?
Yeah, so I work in an area of mathematics called group theory, which for me, I think of it as trying to understand symmetry, really, in its most general sense. So shapes have symmetries, but we can also look at any kind of structure and look at what you can do to that structure to leave it looking the same. And really, group theory it's kind of algebra that is incredibly useful for understanding those symmetries in their most general form. I love group theory so much because it gives you a structure that you can play around with. And there's only 4 rules that tell you that a group is a kind of set. There's only 4 rules that describe it. But from those 4 rules, there's a huge, incredible richness of structure, of beautiful objects that we can play around with and study. So I think about mathematics as really playing and exploring interesting ideas. So group theory is what I started out with, and it has applications all over mathematics and beyond, which makes it even more fun.
And is that where the story aspect comes in then? Because it's exploration, so in a way you're going on journeys when you're exploring mathematics, and it gives is that how kind of the narrative aspect comes into maths when you're actually doing it?
I really feel, yeah, absolutely. The narrative is so important. And if you think about, as a mathematician, when you're describing or explaining to a fellow mathematician what you're doing, you want to tell them a story. Like, I saw this interesting thing, and then I wanted to find out more. And so I explored, and then I wondered if there were other things like this. And so you tell a story about what you're doing, and you feel as if you are exploring and discovering a new realm. And so the story of that exploration is then the compelling thing that drives you forward. I want to understand this new place.
So you went on to become a professor of mathematics, but you were also the president of the British Society of the History of Mathematics from 2020 to 2023. How did this interest in history come about?
For me, I think mathematics is part of our cultural story, right? It's embedded in the story of human beings, finding things out and thinking and exploring and wondering about our world and who we are and our place in it. And so mathematics has always been part of history as well, and the story of mathematics as a subject and how it's developed and how we have learned to think about the world and even think about abstract ideas is kind of, it's a crucial way to understand not just mathematics today, but our human story. So history broadly, but the history of mathematics in particular, for me is fascinating. And so I've been always trying to include it in my teaching. And I think, when I've included historical ideas in describing mathematics, that my students have really, really enjoyed it. Just as an example of this, I talk about, I study group theory, and group theory begins with saying, here are the 4 rules, like axioms, that define this structure. And without any context, it feels very odd. Like, why these rules? Why these, why not others? What's so special about this? And you can almost get the impression, which is really not true, that somehow mathematics is this crystalline, perfect thing that is descended or written on stone tablets, decreed by people who we could never hope to emulate, right? And so students think, I could never be a mathematician because of that wrong impression. So what I try to do when I teach these subjects is to say, look, actually, these ideas took ages to crystallize. It took ages to become formed into this perfect thing that we now present, right? The idea of a group was first conceived in about 1830, but at that time only one of the rules was stated out loud because the others were sort of implicit in the situation. It took about 50 years for mathematicians in all areas to kind of think about what should be the rules, what are the things we need. And so, to tell your students, here are the rules, now go, in 3 minutes is not going to help them to appreciate. These rules are carefully chosen from all the many possibilities by people working for decades and decades to think what is the best structure and the choice. So mathematics, again, it's part of a story. The narrative of how mathematical concepts come into being is so important to situate ourselves in the story.
So do you think that perhaps mathematical papers or mathematical proofs lack that too? Because they are often written slightly the wrong way around. They're often written in the reverse order from how you actually think about things. Do you think it would help mathematics as a whole, not just students, but everyone, if people were more explicit about the context in which they came to their results?
Yeah, I really, really do. And I think sort of historically, if you think about mathematical papers, in the olden days, you had page limits, you had only a finite, it was expensive. The more pages you wanted, the more it would cost and all of this. So maybe that's why we developed this style of writing very, very concisely. But what happens when you're doing mathematics, you play around, you try some examples, you try a few special, small, easy cases, and then you get a feel gradually for what's going on. And then you come up with, I think this thing is true in general. Then you work and play and establish a proof that you have. And then you throw away all the scaffolding and present this finished artifact, which is, may be very elegant, but anyone then reading that has to unpack. And probably for themselves, they're writing down, let me try a few little examples and see if I can work out what's really going on. So for me, the way in which we present things, it might be like super, super short and elegant, and every phrase actually covers 17 different cases and you have to unpick them all. But I think it can be taken a bit too far in terms of actually trying to explain to something that everyone will grasp. And I would say we do a lot better actually to say, describe, contextualize the background of why we're interested in a particular thing, and then say this example and this example will show us the bare bones of, or like, the gist of the idea. And then, of course, you still need to do the formal proof, yes. But when you get to that point, actually a few diagrams, right? A few examples and a bit of here's why we care and here's what we're thinking of when we're writing this sentence is so, so helpful. And actually when you give a seminar or something, that's often what you're doing. And then people can read the paper afterwards. But yeah, I think we could do a lot better with that kind of expository.
One area in which we use this more contextualized approach to describing mathematics is, of course, communicating to non-experts. And this is something you do brilliantly, not just with your books, but also you were a Gresham Professor of Geometry from 2020 to 2024. You were the first woman in that chair since it was established in
1597. Yeah.
Can you explain what is the role of the Gresham Professor of Geometry and what you did in that role?
Yeah, so Gresham College is a very unique institution because it was founded in 1597 in the will of Thomas Gresham, who was a Elizabethan financier. When he died, he said, he wanted to leave money to form a college that would be, its purpose would be to provide free lectures to anyone who wanted to attend. This is like, over 400 years ago. It's fantastic. And so originally there were 7 professorships, which kind of reflected the knowledge of the time. So geometry was one, and now that's more broadly any mathematics you can speak about. And then there was music, there was medicine, so physic was the name for it. There's law and divinity, right? So theology. So 7 subjects and 7 professors, and they would give lectures, in London to anyone who wanted to come. Originally, you would have to give each lecture twice, once in English and once in Latin. But thankfully, my Latin isn't very good. They dropped that requirement after a couple of centuries. But so the job is to give public lectures, and so it's communicating mathematics to anyone who wants to come. And so that ranges from nowadays, you'll often get school groups that will come, sixth formers or people doing A-levels, but also working professionals. You get people who've retired. So anyway, it's a whole range of people, all ages and all levels of experience. You get people who have studied mathematics and people who haven't. So, that's a challenge to appeal to and find something for everyone in that audience to learn something new, but, not to be like left behind. So a narrative, a story is super important for that. And I absolutely love being part of this continuous tradition that's, started in Tudor times, right? And now is still going. And, some of the people who have held that professorship previously are like, big names like Robert Hooke. I think, gosh, I've got the same job as Robert Hooke had. And Roger Penrose did it, and Christopher Zeeman did it, and Ian Stewart more recently. So, it's lovely to be part of that lineage and to think, the Royal Society was actually founded at Gresham College. People would meet up after going to lectures, and then they formed a little society, which I believe is still going strong. And Christopher Wren, he was the astronomy professor for a while. So all of these people are connected, and I love being part of it.
It's amazing. It's amazing. What did you do? Give me an example of things that you did.
Yeah, so I made my kind of broad theme to be the links, the connections between mathematics and other cultural things, other arts. I think of mathematics as an art. So I spoke about the connections between mathematics and music and with literature and visual arts. So we talked about the development of perspective, and we talked about, symmetry and beauty in art, proportion. Then I talked about some of my favourite curves. So the cycloid, which is something I talk about in my book, which is mentioned in Moby Dick. But this is this really fabulous curve it's very simple idea. You make it by imagining a point just on the edge of a wheel, and then you roll that wheel along a road and you see what happens to that point, and it makes this curve called a cycloid. So it's a really great opportunity for me to just tell people about fascinating mathematics and weave that into a story about the links with the arts more broadly in culture.
It's interesting you say the connections with music as well. We talked to Rob Easterway the other day, who's written this book about maths in Shakespeare, but also maths in Shakespeare's time.
Yes.
And he told us that at university at the time, music was a subsection of maths.
Yeah.
So it's interesting, isn't it?
Yeah, it's absolutely. And I think, if we think of the kind of the traditional 7 liberal arts, right? So you had the trivium was the kind of the basics of speaking, like rhetoric, grammar, logic, thinking. But then the quadrivium, which is the kind of more advanced 4, were thought of as being, really mathematical things. So you had arithmetic, which is like number, and you had geometry, which is like numbers, but in spatially, and then astronomy, which is, again, numbers, but sort of in space and in time, and then music, which is number as it's perceived in time. So those things are all connected, and music was definitely viewed as a mathematical art, and it absolutely, it is. If you think, there's obviously counting there in the rhythms, but there are so many other connections. It's fascinating, yeah.
So Sarah, you've been recently attending some of the modern history of mathematics workshops here at the Newton Institute. How's your experience going so far?
Oh yeah, it's amazing. The Newton Institute is a wonderful place to be. As a mathematician, it's paradise, right? There's blackboards everywhere, there's books, there's the ability to make as much tea and coffee as you want. So, Fabulous place to stay and do mathematics. Really, really great. The Modern History of Mathematics program is so exciting because it's the first history of mathematics program that the Newton Institute has run, and its kind of key focus is on it's a challenge of how we look at and describe the history of mathematics as we come to a time, kind of 20th century mathematics, where the complexity and level of the mathematics that is being done at that point means that if you're going to study the history of that topic, you have to both be a good historian and a good mathematician at the same time. And I think looking at how we tell those stories is a challenge for mathematics and for historians of mathematics. And some of the the workshops and the lectures have been just incredibly fascinating by people who are working in all areas of mathematics and in history of mathematics. And looking at, it's not just looking at 20th century mathematics as well. It's how modern techniques and modern equipment and technology can help us to get new views on history of mathematics going for the whole range of time. So the amazing things that are now possible with like the digital humanities and things like this just open up entirely new areas which are going to be fascinating to study. Can we use AI to digitize things? Can we use AI to read thousands and thousands of pages of documents that we previously, we don't know what to do with them when they're in these archives? And can we understand and find things that we haven't seen before? So these are all really exciting opportunities. And the program is very timely and fascinating. Yeah.
So apart from studying and teaching mathematics, of course, how do you use maths in your daily life?
Well, if you ask my children, they say to embarrass us when we're out, right? Because I have teenage daughters, and I'll say, well, we'll be just walking along the street innocently, and I'll say, oh, look, that bus number 257, that's a very interesting prime number, girl. Did you know? You could never like, oh, Mum, stop it. So that embarrassing your children is a key use of mathematics. I think for me, I see, like many mathematicians, I imagine, I see patterns right everywhere. So if the patterns that we see in nature all around us, if you go for a walk, you will see mathematics happening. You'll see the flowers. It's springtime at the moment, and so there's flowers coming everywhere, and you have a look, and this one's got 5 petals, and this one's got 13 petals. And you see, the Fibonacci numbers, or you see, the trees in their fractal formations. So I I mean, one does use mathematics in the sense of course, we have to. I'm doing it in my job, but also if I want to do something efficiently, I might think about a mathematical way to do it. But it's just there all around us. If you have a cup of coffee in front of you and you see that weird little curved shape that sometimes, if the light is right, and you could think about what is that curve and where does it come from and why is it that curve, and you find that it's called a cardioid, and you make it by rolling a circle around a circle, right? Links to cycloids. Isn't it great, right? So this is what I do in my day. I just sit there and stare into space and think about patterns. It makes me happy.
Yeah. So given that you see that, I mean, I'm sure most mathematicians have that sense of that it's everywhere. But given that you've done so many things with the history of maths and the Gresham professor and book writing and mathematical research, what would you say to an early career mathematician or even somebody at school, right, who's enjoying maths? What advice would you give them about being a mathematician and embracing all that there is as well in that job?
So I do sometimes get asked, how did you kind of decide that you were going to become a mathematician who was going to write a book about literature? And there is that is not a decision, right, consciously. So when I started out as a mathematician, I knew I loved mathematics and I wanted to study it, and I did. And of course, if people who love mathematics who are thinking of doing that, it's a great thing to do because it's so much fun and exciting. But what I also did, and not in any strategic way, but I had, of course, like everyone, I have other interests. So always reading. I enjoyed music as well. I like playing the piano. So those things I carried on doing without any thought that, this will somehow be useful one day. But the thing is, if you do the things that you find fascinating, and if you indulge in your passions, that the things that just make you really, really enthused and excited, everyone's going to have a unique collection of those. So there'll be a point where there'll be a project or an adventure that only you can have because you've got your own collection of things that are unique to you, and that combination can lead you to an exciting place. So with me, I was always reading. I wasn't thinking maybe one day I'll be writing about this children's book, The Borrowers or whatever, that I loved when I was a kid, or fairy tales that I was super, super into. I wasn't thinking one day this might be useful in my career, but it just so happened that particular interest of mine with the mathematics that I've been studying made for an interesting exploration. So I'd say to anyone, do the things that you love, and then you'll be able to combine them maybe one day.
So that's it for this edition of Living Proof. We will put links to any relevant content and information in the show notes.
And you can listen to Sarah talking about her book Once Upon a Prime and the links between maths and literature in an episode of the Maths on the Move podcast from plus.maths.org. We'll put the link in the show notes as well. If you've enjoyed listening to this podcast, then please recommend us to a friend or rate and review us on whatever platform you're listening to. It'll really help others find our podcast. Thanks very much to Sarah. Thanks for listening, and bye for now.